Hello everyone. In the course of working on use cases, we found a useful tool for drawing sequence diagrams. It's called Draw Express and is available on iOS. If you have Windows, then definitely check out Diagram Designer. It's a similar and recommended tool. Sequence diagrams are useful for figuring out problems with your protocols. In this case, I sketched out what might happen with an ARAP that goes in and out of communication with the satellite. I chose it because I wanted to test the tool, but a question immediately arose from this drawing. What happens with the local audio if it can't be shipped up to the satellite? Is it just dropped on the floor? And how do you respond back to a particular FM radio if they are on different channels? These are the sorts of questions that we are digging into. On Wednesday evening, we had our weekly Ascent conference call. Ascent is the CubeQuest Challenge project. We collaborate with Ascent and share some engineering. The top priority for Ascent right now is the modem. We talked about several options and decided to investigate using DVB-S2 modems. The question is, can we slow them down enough to use them on the Ascent project? How slow? Well, we discussed 300 bits per second up to 3 megabits per second. Carrie, N6IZW, was familiar with some work going on in France with amateur DVB-S, and we're going to start researching and documenting as much as possible in order to support the Ascent modem effort. In order to comply with ITAR, finding someone in the US that will take the lead on this part of the project is vital. If you know of anyone, or you want to be the one, then please get in touch with me, and I will put you to work. You don't have to be an expert, you just have to want to become one. And we are here to help with that.
So I demoed whatever I wanted to.
This is the meanest person in the whole AMSAT universe. Mean. Okay, now do it again. I'm going to poke you. Poke you.
Okay. So there's receive audio. Channel 1 is 146.025. Have to defeat the radio's repeater shift. So there it is.
That's great.
I switch channels, and it doesn't show up until I change frequencies to match. Now it does show up.
Okay, so Paul just said if you need us to explain GNU Radio to you, then you're in bad shape. But what we're going to do is we're going to walk you through our understanding of what we have currently. Okay,
Yeah.
Ready? Here we go.
So this is the flow graph as we've edited it to be on one side of our split link. It doesn't work yet, so take this with a grain of salt. But this first part is as it was originally provided to us. So this block here is a usurp source, which just means it's the receiver. And it provides samples to the polyphase channelizer, which outputs 4 separate channel stream or sample streams
All the time.
all the time. All 4 of these go into these Qt GUI frequency sinks, which are just the visualizers that generate the on-screen graph. But they also go through this Y connection here to individual resamplers. And then each stream goes on to a narrowband FM receiver and goes on to some arithmetic conversion and then to a mu-law channel encoder. And I'm going to scroll the screen because you can't zoom it thanks to X Windows.
Thank you, X Windows.
So here we are. The mu-law audio encoders all feed into these multiplexers. The multiplexer grabs this vector source, which is just a sync vector, I guess, for each, or maybe it's guard bits or something like that. Yeah, it must be guard bits for each of the streams. And then all 4 of these streams go into this multiplexer together with, and it gets peaked at by this time raster sync, which is just another on-screen visualizer. The multiplex stream comes in here, gets unpacked, and packed again. I'm not sure what that's all about, but it's something relevant to how the data format works.
Maybe they'll tell us.
Then it gets turned into symbols and multiplexed with the preamble, fixed preamble by this multiplexer here. And now we get to scroll again. I can't see the scroll. There we go. All right, scrolling over here. And the multiplexer comes out to this root raised cosine filter, which is the channel transmission filter. And this is your antenna, basically. simulated by the USERP sync, which takes those samples in and generates a transmission at our assigned frequency, which I've chosen 1.25 gigahertz for test purposes. I'm not sure what I need to hook up to this command port. It probably has something to do with the fact that it's not transmitting yet. The other side of the flow graph has been moved over to the other USERP, where it receives and tries to correlate with the preambles and then demultiplex the individual 4 streams.
Let's go over there.
Okay.
Rolly chair activate. Whoa. Okay. Whoa. Here we are.
Okay, so here's the rest of the flow graph. This point here was originally connected directly to the root raised cosine filter on the transmitter, but now it's connected to the USERP source directly. So we get a receiver here at 1.25 gigahertz feeding samples into the receive filter. It goes into a correlator looking for the preambles, and that's where the visualization of correlations comes from on screen. And then it just decodes it all through all this stuff. This pulls out the right bits you want, decodes the constellation, maps it, blah, blah, blah. I don't know exactly what all this stuff does, but it essentially just receives it. Now we're down to the mu-law decoder, some arithmetic conversion. We get to peek at it again with another spectrum analyzer if we want to look at the received audio. And then into the audio sync where it plays out through the speakers.
Woohoo!
And if we're actually transmitting, this would possibly work.
Let's try it.
Right now we're getting underflows like crazy, though, so we better start and stop this one again.
Okay. All right. Take 47. Welcome to GNU Radio 101. We downloaded a QPSK example, or PSK example. They set it up to where it was doing this. Here's the constellation. There's our flow graph with a sync, and multiply, and PSK modulator, random source. Up here is a constellation sync, which gives us this handy thing. And guess what? It's transmitting. Okay, so step in the right direction. We were having a lot of trouble earlier getting it to transmit when we pulled apart our GNU Radio symposium demo. But anyway, one step closer. GNU Radio is pretty awesome. Wish we were a little smarter with it, but that's going to happen with some time and practice. All right, here we are.
It's still jury-rigged to transmit noise.
Yeah. Okay, so we've hacked up the symposium code to transmit noise. And sure enough, we are transmitting noise. Okay.
Lower than it was before.
Well, I did twiddle the knobs. Okay, we're getting rid of the noise test, and we're hooking up the actual outputs to the actual transmitter. And we're trying it. Hoping it'll work this time, now that we got some basics out of the way. Oh.
Lots of underflows.
Yep, got lots of underflows, but there's something there. But lots of U's. You.
Not right.
No. Okay. But hey, that's a big deal. It doesn't seem to matter which way that you point it.
Yeah, I don't think it's only getting across the room.
Okay.
Another active area of discussion and research this week concerned the possibility of a dual-band feed for Phase 4. The baseline design is to have separate transmit and receive antennas for the radio. Tom Clark presented a 10 GHz receive system at AMSAT Symposium, and his paper is available in the Phase 4 repository. There's every confidence that a dual antenna system will work. In the course of developing our requirements and use cases, there was consensus about ease of use, and pointing 2 dishes instead of 1 was not considered to be easy to use. Pointing a receive antenna is one thing, but pointing a transmit antenna is another. Even with an assist with EBNO reporting, it's a hassle. For emergency use, 2 antennas is not as desirable as 1. So we started researching dual band feeds, and we have a preliminary design. Paul Wade, W1GHZ, David Smith, W6TE, and Kent Brittain, WA5VJB, are involved in this part of the effort. I'd like to emphasize that this is an example of the type of engineering spirit I want to encourage for the project. We are not one size fits all. If we can figure out a couple of different ways to do a particular aspect, then it gives hobbyists and experimenters a greater palette to work from. A simpler, easy to make or buy solution allows you to get on the air faster. A recipe for a higher performance part might be harder to make, but may allow you to relax some other part of the radio design, or it may allow you to use a wider variety of parts or subsystems. What particular function that you're most interested in, that solution may provide it. We're trying to come up with an ensemble of solutions. If you can tolerate pointing 2 dishes, or are going to operate from a fixed location, then use 2 dishes. If you want a portable solution, or you want to build your own dual band feed from our specs or models, and if it works, then you can do that. In no way does this mean one solution is inherently better than the other, or is being ignored. There's a tracking document for what we hope to be at least 2 antenna and feed solutions in the repository right now. Like everything else, it's a work in progress. But if you are interested in 5 and 10 gigahertz dual band feed design, find some time to check it out. If you're able to contribute in any way, then we welcome your time and attention. Join us.
Okay, here's the dual band feed of ill repute from Whiskey 6 Tango Echo. Comes with the QSL card. Thank you so much. That's outstanding. All right.
Comes with lots of green
Lots
bubble
of
wrap. too.
green bubble wrap. Green screen something on that. Oh dear. Oh.
That's going to leave a mark.
That's
That's the whole thing. Right?
yes, that's the whole thing. Oh dear. That's kind of
You
neat.
see down in there?
Yeah, I can. That's pretty cool. Okay, so this is, we're going to examine this and we're going to study it. And then we're going to figure out if there's anything that we can learn from it going forward to make a dual band feed for this project or for any other. Anyway, thank you. Thank you very much. We will do it justice. Okay, let's see the business end again. See if there's any asphalt still in that.
This way.
Yeah, oh dear. Yeah, this fell off a moving vehicle and was dragged for a little bit. It did leave a mark. So it has history, people. History.